Hey, good afternoon, everyone. Good afternoon. Can you guys hear me? Hello? Hello? Hey, good afternoon. So I guess you guys can hear me. Somehow I can't hear myself from my another computer. Yes, the volume is okay. I don't know why. Okay, let me increase the volume on my own. So can you hear me? Oh yeah. Now I got it.
Hi, good evening, Professor.
Hey, good evening, Malaysia. Hi.
Good evening, Professor.
Good evening. Happy Thursday. Shanaz, how are you? All right. So let's see. Yeah, I guess we have pretty much everyone. The usual members. Okay, let me move myself. And give me just a few minutes. Every time the setting has changed on my other computer. This is okay. So much resources. All right. So we still have about 10-minute portion left. About 10-minute portion left on the video number 2 on future value of annuity. So we're gonna wrap it up and then move on to the next lecture. Okay, so let's take a listen. It's moving on. What's going on?
Give it the rate in payment. We can do it by, okay.
So yeah, this part.
What about this? Yes, you can do it by, you scroll down until you find payment. There you are. Hit OK. Give it the rate. Give it N. No present value, but future value, right? Ordinary, type ordinary, right? So you don't enter anything or enter 0, and then hit OK. You got this already. Oops, something went wrong. Okay, where did I go? Let me backtrack. Oh, the formula was already in. So because that's positive, and then this is going to be negative. It's going to be okay. I forgot to delete the formula that was already in there. Hit enter. Oops. And then I forgot to equal sign, right? I have to have equal sign. There you go. We got the but then all these things turn to negative. Why? Because look, previously this was not negative, right? And we made it negative in the formula, right? We made it negative in the formula, right? There you go. So we made, but because it was not negative at, previously, we made it negative. So think about it. Now this is already negative, and you make it negative again, then it's going to be positive. So that's why. So you make it, you take out the negative sign, then this will be A8 by itself is already negative. So you get that, right? And then again here, this thing is weird, right? This negative 86 months. There is no such thing as negative time. So the reason was because A9 was already by itself already negative. So I'll make it negative here, then it's going to be positive, right? Or we can even, okay, we can solve for that using also Excel's built-in function. So we're solving for n. So it's n periods, right? Okay, give it the rate. Give it the payment. The payment is already negative. You just enter it like that. Give it the future value. Type, just leave it blank because it's ordinary. And you see 60 already. Hit OK, you got 60 here, right? So once again, you can solve it either with Excel's built-in function or by formula. But no, I want you to use formula. Why? Because Excel's built-in function is like a GPS. Now, if you rely on GPS, right, when something happens, something goes wrong with GPS, then you become completely an idiot, right? Why? There's no mental map in your mind. There's no mental map. And if you just, so get so used to relying on GPS, what happens is you know the area, you know how to get there, you know where to make the turn, you know where to. Even if you don't know, even if you know the area well, you just wait for the prompt from the GPS, like in 500 feet, make a left, right? In a quarter of a mile, make a right, right? Make at the next intersection, make a right, or make a left. Now the problem is sometimes the GPS prompt is a tad bit too late, just a tad bit too late, or I mean, GPS, there's a delay. Sometimes when there's a lot of traffic, GPS has a hard time finding. I mean, if you're going through a multiple interchange, a multiple layer interchange, you're on the, like, there are like, 4-story, 4-layer highway interchange, and you are at like a second level. The GPS thinks that you're on the 4th level or 3rd level or on the bottom, level, and then it misdirects you. There's no exit in the 2nd level, but in other words, there are so many cases where GPS can go wrong. For example, waiting for the prompt. You have to make the right turn, but sometimes waiting for the prompt is a bit late, and you have already passed the intersection. You cross the intersection, then it's saying make a right. Or in the middle of crossing the intersection, is giving you that cue, make a right. It's too late, right? If you make that right turn there in the middle of the intersection, or as you are, unless you get into an accident because you're making an very abrupt, sudden right turn, the car behind you will hit you, right? So that's the downside of relying on GPS. You become a complete fool. You become an idiot, right? You have to make a right, but you're waiting just for the. Sometimes you're completely, your mind is completely devoid of that mental map. You got so used to, right? So when something goes wrong with the black box, or when something goes wrong with the GPS, you can't fix it, right? If the satellite is fried, right, hit by an asteroid, the GPS goes off, all right, or it may give you a wrong direction. That's the same thing. If you rely on the Excel's built-in function, right? If something goes wrong with Excel, or if something goes wrong with the Excel, then it's totally will be an irreparable situation. But if something goes wrong with the built-in function, you can't fix it, right? But by using the formula, right, you can overcome some glitch in the built-in function. All right, so that's it for this lecture.
Well, okay. So the reason I showed you Excel's built-in function how to use Excel's built-in function is not to encourage you using it. I really don't encourage you to use it. As I explained, you are, you're just turning yourself into a data puncher, nothing more than a data puncher. And besides, you have to make always, distinction. You have to make which one. You have to make that decision. Which one has to be expressed as negative? Actually, in the video, I've already explained that negative is not. This is not really minus 859. It just means that's cash outflow, right? Because that's the basic financial calculator setting, right? In the financial calculator, you have to make distinction between cash inflow and cash outflow. Now think about it. If you make these are monthly deposits that you make, or monthly payments that you make, and 60 months later, it's gonna grow to, it's gonna grow to 60K. And that's going to be your cash inflow. This is going to be cash outflow. So it's that distinction, right? So, but you have to make that distinction in the when you type in when you enter those variables into the Excel's built-in function. If you make a mistake, then it goes terribly wrong. And that's why I simply, that's the reason I showed you why, how to use Excel's built-in function. Okay, all righty. So we're gonna move on to the next video, which is okay, let me go to topic 3. Now, present value of annuity, right? If there's future value of annuity, there's got to be a present value of annuity. Let's take a listen.
The time value of money that we have been talking about, we have been discussing for the last several weeks, and we completed the single cash flow model already a couple of weeks ago, and we've been on discussing the multiple cash flow model annuities for the last couple of weeks. Now, in the in our last class, we basically did an Excel exercise of future value of annuities. So we're moving on to present value of annuities today. Okay, so some of you may have already wondered that if there is future value of annuity, then there must be present value of annuity as well. Yes, of course, there's a present value counterpart to the future value of annuity. Now then, what would be the present value of annuities? Well, to give you a brief example, let me go to this one. Let me go to this slide where you have a typical example of present value of annuity. This is an example of ordinary annuity. Remember, also in the future value of annuity, we talked about the difference between ordinary annuity and annuity due, where the ordinary annuity is an annuity that makes a payment, or where you make a deposit at the end of each period, right? Whereas the annuity due is a case where the payment deposit is made at the beginning of each period, right? So this one is annuity, ordinary annuity, and this one above is annuity due. See, the payment starts at the end of each period. Now, so if this is future value of annuity, right, we will define the future value. In other words, this $5,000 deposited or paid at the end of each period, and what's it going to be in 5 years, something like that, right? Second deposit, what's the future value going to be? Third deposit, what's the future value going to be? Fourth one, right? That is the future value. In this case, that's clearly present value. So in this example, you are receiving an annuity because I defined annuity already last time, so I'm not going to go over it again. But it's a regular amount paid or deposited at the end of, at regular interval. And this interval is annually. In this example, annual. The interval is annual, and it's made at the end of each year. So if the discount rate is 10%, right? The $5,000 received at the end of each year, right? And the first year, at the end of the first year, is discounted once, right? And the second $5,000 is discounted twice. Third, discounted 3 times. Fourth one, discounted 4 times. Fifth payment or deposit, discounted 5 times. And the present value is sum of all of this. Now, in case of annuity due, right? It's starting at the beginning, so the first deposit or first payment isn't discounted at all because it's already in the present value, right? Now, for some of you who may be wondering, why isn't it the professor? You just said, this deposit isn't because this payment isn't discounted at all because it's at time 0. It's already present value. Why is it discounted? Look at this. It's just uniform structure, but it is, the denominator is 1.05 raised to 0, right? Anything raised to 0 is 1. So this is, nothing, right? It does nothing. It's just to keep it in uniform structure, right? Now, so we get the idea of present value of annuities, but this is a small scale example. This is only a small scale example, very small scale, right? Scale down example, because in reality, you don't see this type of small scale example that often. And in reality, you might have to deal with something more realistic, something like this. So let's take this example. You want a $10 million lottery. And then you have 2 options. That is one, that's got to be, right? Number 2 options. Either receive lump sum cash payout of $6 million after tax today, or $20,000 every month for the next 30 years. Okay? And currently the prevailing market interest rate is 6%. What say you? Or what do you pick? What's your decision? Now, so this would be a very happy dilemma because you won the lottery. As I said, and this dilemma is basically whether you choose lump sum or you choose annuity. Okay, and if you choose lump sum, you receive, you pay about 40%. It's actually 39% because 39% is the top tax rate. Okay, and regardless of your earned income, right? You pay 39% on a windfall gain, like lottery. Now, if you remember, the topic 2 was financial statements, and in Connect, right? In Connect, if you did chapter 2 practice problems, you would have encountered many tax problems, right? Now, and from that example, you must have learned that when you pay tax, right? It's not like a you go through. It's not like you're paying a fixed percentage of your entire taxable income. Your taxable income goes through multiple tax brackets, right? So your effective tax rate is not your top tax rate, but I mean your top tax rate may not even come to 39%. It may even your top tax rate may even stop at 30% or 25%, depending on, or 28%, depending on your taxable income. But regardless of your taxable income, right? Regardless of your earned income, taxable income from your earned income, you pay the maximum rate on the windfall gain, right? Because jackpot in the lottery is not what you earned. You were just lucky, right? It was that's called unique card rate. So it's not an earned income. It's just a windfall gain. So you pay the top tax rate, okay, of 39%. So 39 is almost 40. So just approximately after 40% taxes, you would get $6 million roughly, right? But then if you choose annuity, then it's like $20,000. I just paid $1,000 for this example, but in reality, it would be a different number. And if I remember correctly, it would be like 26,000 something. And then in reality, right, it's not 30 years. It would be they don't pay it over 30 years. They pay it over 29 years. But that doesn't matter. in our example, because it's a thought experiment, we will just assume 30 years because it's easier to work with an even number and round number than just 29 odd number years, right? Okay, so if you are receiving like $20,000 every month, you might wonder, oh, 30 years is 360 months. So 20 times 360, I would come to 20,000 times 360. I would come to $7.2 million, right? And you might say, I should go for the annuity because that's, 7.2 million. Look, first of all, this is a pitfall that most lay people fall into, right? People who don't have any training in economics or finance easily tend to fall into that pitfall. Why? First of all, 7.2 million is a simple aggregation of these $20,000, right? But think about it, 360 of them. But think about it. This 7.2 million doesn't exist anywhere at a single point in time, right? That's what you must remember. And as a student of finance, as a as someone who is being trained in finance, you should have you should invoke the concept of present value, right? Because like in this example, this small scale example, right? All of these $5,000 don't exist, at a single point in time. They are all spread over 5 years. So you cannot simply say, oh, that's 5 times 5, so that must be $25,000. No, you can't. That's someone who has no training in economics or finance. Why? First of all, that $25,000 doesn't exist, right? The only way you can aggregate them, when you're aggregating those, if you're adding up those numbers, they must exist at a single point in time, right? And when they are in the future, you understand there's a time value of money, right? You cannot take them at face value. You must discount them. That's what the present value is all about. So you have to find the present value of all those $20,000, right? To make a comparison with $6 million. Make sense? Because that all those $20,000 spread over 360 months are like oranges, and today 6 million is like apple. You cannot compare apples with oranges, right? So the only way you can compare them is by converting all the oranges into apples, right? And then of course we cannot actually, we can do this because we're talking about the dollar value. Of course, physically you cannot turn oranges into apples, but when we are talking about this is an analogy only, right? And then all those $20,000, which is future cash flow, right? Stream of future cash flow, which is called annuity, because they are all regular amounts at regular intervals. You can turn them into present value, and you can compare it with $6 million. And your decision is what? Whichever is greater, that's what you pick, right? So then we understand how, but then we know it's with the examples like we have, it's impractical. You cannot do it this way because it's all $20,000 spread over 360. So you will need to deal with 360 of them. That's practically, that's totally impractical, right? There's practically no way you can, although it is not impossible, but it's going to be very, very tedious to, add it up like that. So that's why we have the formula, right? And this is the formula for present value of annuities. But then next question is, where did this formula come from? Well, we're going to get to that, but first, we're going to get to that later. So let's summarize our thought procedure, right? Our thought process, right? So let me use the whiteboard and have to all the annuities, right? So first, remember, $20 is our payment. It's the payment we receive, right? And we receive that payment at the end of each month. So the first payment will be discounted by monthly rate once, right? I don't have to write one there, but just to make it clear. And the second payment will be discounted twice, right? So squared. And then third payment will be discounted 3 times, and the ellipsis. I'll just use that wave tilde, right, instead of ellipses. I'll just call it ellipsis because I cannot just put. It's very difficult to put that right? A string of dots, right? With the mouse, right? It's not going to come out. So then come to there are 360 payments, annuity payments. So the last one will be discounted 360 times, but the one second from the last, right, or 359th payment will be counted 359 times. But instead of writing actual number there, let's call it t minus 1. We'll raise it to t minus 1. Because the terminal t, uppercase t means terminal time, which means that's the maturity, right? Now that means the last payment will be discounted 360 times, but instead of actually saying putting 60, 360, the number there, we'll just put uppercase t, okay? So that no matter what t may be, it can be 180, 30, or whatever, 60, right? So we can handle that. So here, then, of course, you understand this is a very tedious. It's going to be very tedious if you have to write every term like that. Because there's a string of like 360 terms, which is called polynomial, very long polynomial, and that's obviously not very practical. But we know better. We know how to use summation sign, right? By using summation sign, we make it very compact, right? It's a way of compressing a long polynomial into a very manageable, concise expression. So that means you are summing up all of these terms with n starting from 1, running all the way to t, the terminal time, and then the reduced form formula. But if you think about it, although this is a nice way of expressing that long polynomial in a very concise manner, actually it doesn't really help you calculate. It doesn't really help you calculate that equation, that formula. Why? Because anyway, to do this, you will have to do all of this, right? It doesn't really help with calculation. So that's why we need to reduce it to a more manageable formula that can actually let you calculate. So then our next one is how did this transform into this? That we'll talk about a bit later, but today I'll just show you the formula, how that formula can be applied in Excel. So it's P payment over R minus payment over R times 1 plus R. Okay. But some of you may have noticed, you may wonder, Professor, isn't that the simplest form that we need? And this isn't really the simplest we can get? If you thought that, this is the simplest, as simplest as it can get. This isn't exactly the simplest it can get. Why? You still see common factor there, right? Right? What's the common factor? Well, common factor is this, isn't it? Payment over R. So in other words, it can be rewritten as, if you factor out, right? I can rewrite it as like times 1 over 1 plus R raised to n, right? In other words, you can factor out this, right? But even though, if you factor it out, then this will be 1, and so it's going to be 1 minus, right? 1 over 1 plus R raised to n. But we're not. There's a reason why we. There's a reason, an advantage. There's an advantage of using this formula this way, a structure, and I'll get to that later. I'll explain why. So now you got this. So then let me go back to let me switch from this whiteboard to Excel. Okay. All right. All right. So you see, this is the file that we were working on last time. We did future value annuity example with this. Now, if you want to scroll down to row 17, And I would like to delete all highlighted cells before we actually do the example. So here, if row 17, actually, if you simply drop the number, drop 1 0, and that's going to be 20K, 20, and would realize that this is exactly our example. Okay, that is what if you choose annuity, it's going to be you're going to get $20,000 every month for 30 years, and it's going to be monthly, right? Monthly $20,000, right? And it's currently, we assumed in the example 6% APR. Well, we know what to do, right? First, we will need to find the periodic rate, which is a monthly rate. So you divide that by this. That's going to give you, we already know the story, 0.5%. And N is total number of compounding, right? Which is this times this, it's going to be 360. And then we're going to find a present value of those annuities. And we're going to use this formula, right? We're going to build that formula there, which is payment over R minus payment over R times 1 plus R, close parenthesis, leads to 360, and close parenthesis. Okay. There you go, enter. Okay, so we got 3.335 million, right? 3,335,832, right? $29. Now, I'm not going to read the number, right? I'm not going to read out the whole number because it's really not necessary. I mean, what's important? That's 3.335 million, right? You can just omit, because it's to call out the number, the full number. That's going to be very, it's time-consuming and it's tedious, right? But 3.335 million approximately, that's good enough. Now, some people may be, relieved or excited that they have found an answer. No. Just, up there, pause there and think about it. Is this the answer? No. What was the question? Answer, when you say answer, that must be the answer to the question. The question only, what's the present value of all these annuities? Well, this is only the present value of those annuities, right? But it's not exactly the answer to your question. What is your question? Question is, if you won the lottery, right? Do you choose lump sum, right? Do you pick lump sum or do you pick the annuities, right? Isn't it right? That was the question, wasn't it? Yes. Then what? If you receive lump sum, how much do you receive? $6 million, right? 60% of the after tax, right? Jackpot price. And I told you you're almost paying 40% as tax. And also, assuming that this is after tax, this is the after tax amount. Most likely it is not, but in reality. But let's assume it's tax after tax, and then this is it comes to 3.335. So 6 million is the present value. 3.335 million is present value. So then what? What is the rational decision? Of course, anybody in their right mind with sensibility, right, or minimum intelligence, will go for a greater value, right, which is 6 million, right? So in this example, in this case, you choose lump sum, right? But think about it. It's the present value of these annuities are this, because the present value is this only because the discount rate was 6%. What if the discount rate is 1%? For example, as I said, I use 6% frequently because 6% is the historical average, right? Historical average over like more than the last 100 years. But in today's macroeconomic environment, and especially quite recently, a few days ago, Federal Reserve slashed the interest rate back to zero, right? And I've been telling you, in people on return on investment, you learned that since the 2000 financial crisis, for a very long time, until like 2015, right, the Fed funds rate was held at 0 to 0.5% level, and that's why all the interest rates are also very low. That's why. And the interest rate was, gaining again since 2006, but they slashed that back to zero again. Why? Of course, we are into another, financial crisis. I mean,
once again, you need to take it with some grain of salt, right? Because, as I said, this video was made in 2020. So the macroeconomic the macroeconomic conditions are quite different now. Actually, Fed raised interest rate quite a lot over the last 2 years, right? Since March last year, right? So our Fed funds rate is now at 5.5. Once again, the range is 5.25 to 5.5, right? That's not exactly at 5.5. It's always the range. Okay. Anyway, so take it with some grain of salt. Okay. So we are rather like this currently. This example is more reflective of current market interest rate. I mean, based on the Fed funds rate.
Not just financial crisis, it's almost certain that it's going to go into recession. So to boost the economy, right, they cut the interest rate. So if let's be more realistic, and if we assume 1% prevailing market rate, right, then it's going to be a different story, right? So how different is it going to be, and how much difference is it going to make? So you select those cells and drag it down. Now, if it is 1%, if prevailing market rate is 1%, the present value is 6.218 million, right? So you have, if that's the case, what say you? Of course, if you're a rational and sensible person, anybody would go for annuity in this case. You see how much effect interest rate has on the present value, right? Now, but some people may say, I'll still go for lump sum. And those people generally, if I ask why, they generally say, well, I don't know. I don't know what's going to happen to me in 1 month, or even in 1 year, or tomorrow, or I may not be around anymore tomorrow. Well, there's a possibility, right? But the probability is like very low, like 0.00001%. I mean, everyone has a possibility of getting hit by a lightning, right? That possibility, but the probability is very low. Right? Of course, the probability of hitting a jackpot in a lottery is very, very low, right? It's even lower than getting hit by a lightning twice in a row, right? So that's why the lottery is never happening to you. That's why you're never winning the lottery, right? Because it has very, very low probability. So think about it. If you're saying, who knows what's going to happen tomorrow? But if you are, unless you're leading a very reckless lifestyle, right? Unless you are very, very, leading a dangerous lifestyle. For most people, probability of something drastic or something tragic, right, might happen is very low, right? That's why you have to base. People plan ahead based on the probabilities by normal distribution. In other words, if the average life expectancy is 85, it means unless you're leading a very dangerous and reckless lifestyle, you will live on average up to 85 years. I mean, under 85 years old, right? But then, if based on that, anybody with a sensible, sensibility and rationality would go for annuity if this is the case, right? All right. Then, what about this? This is present value of annuity due, right? And what did I say? The difference between annuity due and ordinary annuity is just one more compounding. Well, I go back to, that was when that was the case for future value of annuity. Does that still hold for the present value of annuity as well? Yes, it still holds for the present value of annuity as well. And let me explain to you. Let me go back to the whiteboard and see why that's the case. So here's the thing. So you remember, let me go back to, again, go back to the slide. Alrighty, so you see this in ordinary annuity. In ordinary annuity, the first payment deposit gets discounted once, and the last one gets discounted 5 times. But in annuity due, present value of annuity do. The first one gets discounted 0 times, or there's no discounting. Second one gets discounted once. The last one gets discounted 4 times. So what do you see? The difference is one less discounting, right? In annuity due, present value of annuity due, there is one less discounting, right? But then you might say, oh, so professor, so that's one less discounting, not one more compounding. No, it's the same thing. One less discounting is the same thing as one more compounding. Why? So let's go back to the whiteboard. Okay, let's go back to the whiteboard. X to the third, right? So this is like discounting 3 times, right? Now, one less discounting means 1 over x squared, right? So then this is 1 less discounting. How do you turn 1 over x to the third power to 1 over x squared? Well, if you multiply by x, right? Then this one of the x's here, x times x times x, one of them gets canceled out with this, right? One gets canceled out with that, so it becomes this. Now think about it. This is like making one more. This is like doing one more compounding, right? So 1 less discounting is the same thing as 1 more compounding, okay?
Yeah, this part is missing. This part is missing narrative. I guess the recording was somehow the recording didn't have a voice. But we're gonna redo this exercise, right? We're gonna redo this exercise after all. So we're gonna I'm gonna explain that, and it's quite obvious what is being what is being said here. Okay, so we're gonna this was video number 1, present value of annuity. So we're gonna move on to present value of annuity part 2. Okay, so and after part 2, we're gonna do some the Excel exercise of the annuities. Okay, so let's take a listen.
This is the continuation of the previous lecture. In our previous session, we were talking about the lottery example, right? As an example of present value of annuity, a typical example being used is a lottery winning case. And as I said, that's not a very realistic example. It's a very pedagogically useful example, but other than the pedagogical value, in reality, lottery may not be a very realistic or down-to-earth example. Now, so this time we're going to be talking about, we're going to be using a more closer to life example, which is about car financing. Okay, so let's take a look at this example. Now you're considering to buy a car through financing, and the price of the car is $30,000, and you want to finance it for 5 years. That means you're going to be making payments for 5 years, but you buy with the money borrowed from a lender, right? You're going to do that with 20% down payment. Okay, 20% down payment of $30K. So $6,000 is put down, right? Now, so the importance of down payment in financing is quite clear, quite obvious. Why? Suppose you're getting 100% loan to buy the car, right? So then, you're getting, the loan of 30,000 and buy the car. But then in this case, the problem arises that there's no reason for the bank to lend you $30,000, right? If all of the money is coming from the bank, why would the bank just, let you use the car, right? Or own the car that they financed 100%, right? Of course, the ownership, the title and legal title to the car is not with you until you pay off. But you basically you own the car, you use the car, but it was 100% paid for by the lender, right? Doesn't that seem odd, right? If that's the case, why wouldn't the lender or the bank just simply buy the car, right, without lending the money to you, right, and just simply rent it out to you, right? So this is why they require down payment, because at least even 5% you put down, then you have your equity in it. You understand? 20% down payment out of 30K means 6K. So that means at least out of this asset of $30,000, right, 6,000 or 20% is your equity, and the other 80% is the debt or the liabilities, right? Then at least you have your stake in it. You have your stake, right? So that's why there is down payment. But anyway, but that means you are borrowing, the amount you borrow is only what, 24K, right? So that 24K is the basically the principal, right, that you owe, and then you will be making payment, over the next 5 years. Usually you make monthly payment, right? So over the next 5 years, of course, then 5 times 12, there will be 12 monthly payments, right? So this is an annuity, right? Every month you're making the monthly payment, and then it's regular amount. These monthly payments are regular installment payments, so they are all constant amount, and the payment is made at regular interval, right? So it's an annuity. And now the question is, the dealership says that the monthly payment is $500. And you might think, if you have no training in finance or economics, then you would think, so if I make $500 payments for 60 months, that's gonna be total of $30,000. So that's pretty much, I owe 30,000. I owe only 24,000. So the total payment is 30,000, and 6,000 must be the interest, right? But once again, this is the layperson's way of thinking, right? A layperson would think of it this way. But now let's think about it. Is this really, is this type of reasoning correct? Is it logical? Right, first of all, your principal is 24,000, right? And no matter what you do, right, $30,000 in total, right? 500 times 60, which comes to 30K. But this 30K doesn't exist at a single point in time. Just like in the previous example of lottery, right? This is just a simple aggregation of all these $500, but that doesn't really exist, right? That 30K doesn't exist as a lump sum at a single point in time. Now, so that's why you cannot make that simple, back of the envelope calculation, like, so 6,000 must be my interest, right? You cannot make comparison that way. And second, even if that was the case, right? Even if that were true, but now let's think about it. If the APR in this example, let's say the prevailing market rate is 6%. If the market rate is 6%, right? Over 5 years, at least even a rough calculation of 6% of, rough, right? Rough calculation of 6%. Let's do this again. Okay, a rough calculation of 6%. Think about it. 24K, right, is your principal, and even annually, 6% of 10% is 2.4, right? 5% would be 1.2, right? 1.2K. So 6% would be 0.12K, right? 6% will be 0.12K. 1% would be 1% would be 0.24, right? 1% would be 0.24. So then 6% would be 1.44K, right? 1.44K a year. Try that for 5 years, right? 1.44 times 5, right? So that doesn't look like just 6,000. I mean 1.44, right? 0.44 times 5 would be more than, right? I mean, even by a rough estimate, right? And we know you cannot calculate the interest a year that way, right? I mean, the total interest that way, because we know it is compounded, right? And this is not even single cash flow model; it's multiple cash flow. It's annuity. So then how do we know if you are making the right payment? I mean, the dealership says that your monthly payment is 500. Is this a good deal or bad deal? I mean, in other words, in your mind, at the back of your head, you would always wonder if $500 is a correct monthly payment, right? Of course, you might think, oh, the dealership could be cheating, right? But actually, dealership wouldn't cheat, right? Why? Because dealership is not the lender, right? Dealership is the bank, right? The lender. Dealership is just simply connecting you with the willing lender, right? And the dealership gets paid when you buy the car. Actually, you make $6,000 down that comes from you, and the bank pays the remaining $24,000 to the dealer, right? To the dealership. So dealership gets $30,000. That's how they release the car to you, right? So the money doesn't go to the dealership. If you're making the payment, it doesn't go to the dealership. It goes directly to the bank, right? So dealership is not necessarily trying to cheat you. I mean, especially with the math, and even think about it, the bank in reality is not likely to cheat you with math, right? There's no way if ever they get caught, there's a severe legal consequences, right, to that. So they wouldn't dare do that. They wouldn't cheat you with the math, right? But in case, I mean, we are doing just a thought experiment. So if there's any fishy business here, right? If there's any fishy business, a very shady business, right? In that case, either how would you know, right? If you think about it, there are two ways you can find out about it, right? Two ways. First, think about it. If this $500 annuity, monthly annuity, is the correct amount, then what should happen? Well, the present value of all these $500 must be exactly equal to the principal that you owe, which is 24K, right? You understand? If this is the correct monthly payment, that should exactly, and if you find the present value of that, right, that should be exactly, right, 24K, right? The present value of all these payments should be exactly 24K, right? Now you might wonder, oh, well, what about the interest? I mean, if they all just simply be equal to principal, how do they make interest? Look, all these, you don't have to worry about it. That's what they have to worry about, not you, right? And from the bank's perspective, they are not doing this for free. In other words, all these payments, right? If it is 500, if that's the correct payment, these payments include both principal and interest. You understand? These payments are not today's dollars. They are all future cash flows. And if they are future cash flows, these are the amounts that include both principal and interest monthly, right? So then the present value of all of them should be exactly only the principal, because interest and interest is already built into this payment, right? And the repayment of the principal are both built into this, right? So that's number one, right? The first way to find out whether you're getting you're making the correct payment or not, right? So think about it. If the present value of all of these annuities are greater than, if that's greater than the principal, right? If this is greater than the principal, 24K, then what does that mean? You're paying more than what you owe, right? And if the right-hand side, the present value of all these payments are less than the left-hand side, right? The principal, then what does that mean? You're paying less than what you owe, or you're ripping them off, which is unlikely to happen, but whatever, for some, glitch in the program, if it happens. But if they discover that that was the case, then they will correct it and send you a revised bill, right? Anyway, the idea is, think about it. The right-hand side is the present value of annuities. You might say, isn't that the left-hand side? Look, of course, the result of the right-hand side is the left-hand side. But think about it. That means if that's equal, then the right-hand side is exactly the present value, right? The result of right-hand side is the present value. And then if it is equal to the principal, right? In other words, if PVA is equal to the principal, then that's the correct amount. Any otherwise, right? Then it's incorrect. Okay. And the second way you can find out about it, right? Second way, you might wonder, can we find exact payment? Yes, of course, we can solve this equation for the payment. In other words, we can nail the exact payment, right? Okay, so nailing the exact payment. So how do we find it? Look, this is the formula for that. If you solve this equation for payment, then you would get this, right? But you might wonder, oh, so how do I get to that? In other words, I've been showing you all along that all these equations, all these formulas, are not separate from each other, or they do not exist in isolation. They are all intertwined. They are all connected, right? Basically, there are 4 equations that arise from one formula, right? Remember, in single cash flow model, right? From that compounding model, you solve it for present value, and then that's discounting model. Then you solve it for rate, right? And that's called, geometric average. And you solved it for n, right? In other words, all these formulas are basically slightly tweaked versions of the original base equation, right? So just like that, we can tweak this to get to this, right? Oops. That's fine. So let's see how we can do that. So let me switch to the whiteboard, right? Let me go to the whiteboard. So, all righty. So everyone can see the whiteboard now. Okay, I hope you can. So let's do that. So starting from the base formula, which is PVA equals payment over R minus payment over R times 1 plus R raised to n, right? Now, remember last time I told you this formula is not in the simplest form, right? I told you it could be reduced further. It can be simplified further, right? And I told you at the time, yeah, because there's a common factor, which is payment over R, right? You find a common factor here. You also find a common factor here. So you can factor out the common factor and simplify it further, right? But and I told you, but there's an advantage to this structure, so that's why I keep using this. But again, we can also, so let's factor out the common factor. But then this time, I'm gonna factor out only the payment. Okay, only the payment. You can factor out, the whole thing for, together. But I'll just factor out payment. If you factor out the payment, I mean, there's a reason why I do that. What's going to happen here? It's going to be 1 over R, and then it's going to be 1 over R times 1 plus R raised to n, right? Isn't it right? Now, but think about it. Why would I want it like that? Because now this becomes z equals, right? You get it? Z equals x times y structure, right? And now we can solve for x, right? This way we can solve for x simply by dividing z by y. And payment happens to be our unknown, isn't it right? That's why. So then next, let's simplify this a little more. So then we can, so PVA is now equal to payment times, inside the parenthesis, what can you do? You can consolidate the denominator, right? In other words, there's a common denominator, not common denominator, but common multiplier, whatever you call it, right? Common multiplier. Common multiplier is R times 1 plus R raised to n, isn't it right? Because you can make this into this simply by multiplying it by 1 plus R to the n, then we have common denominator, right? Now, since you turn this into this by multiplying this, you have to do the same thing, right? The numerator, you have to do the same thing. So the numerator will be 1 plus R raised to n, right? And then this doesn't have to change because it was already R times 1 plus R to the n, right? So it still is 1. Now these two fractions are consolidated or combined. This is still stronger z equals x times y structure, right? This is z, x, y. So now solving for payment, what do you need to do? And payment is z divided by y. So that's PVA. Okay, dividing by something is the same thing as multiplying by the reciprocal of the number, right? So reciprocal is something raised to -1, right? This thing in the bracket raised to -1. This is 1, right? -1. So then if I rewrite it, it becomes PVA times r times 1 plus r raised to n, right, over 1 plus r raised to n minus 1. Okay? Okay, I wonder if I can. Okay, I'll have to use the mouse only. Alrighty, so that's how that formula came about. Okay, so then let me switch back to the, this time I'm going to switch back to Excel so we can go straight to our example. Okay, now we're into Excel, and you see that this is the, we were doing this example before, right? And this time, right, that was the lottery example. Well, what about this row 16? In row 16, this is like our example, isn't that right? First, we'll find out if your if our payment is correct, monthly payment is correct or not, which is simple. We will check if the present value of annuities is equal to 24K, right? So we'll just we'll just copy the formulas in R and N, and then present value of annuity is simply payment over R minus payment over R times 1 plus R times these two, N, close the outer bracket. Okay, now hit enter. What do you get? Oh, this is the present value of all these $500 annuities, right? And which is what? Which means this is greater than the principal that you owe, which is 24K. So this is the proof. This is the evidence that they are ripping you off, right? You're being overcharged every month, by about. So what is the correct payment, and how much are you being overcharged every month? Of course, in total, we know you're getting overcharged by like 15,862. But by using this formula, you can nail the exact payment. Okay, so let's do that. So we know our present value of annuity is 24,000. Has to be, right? The principal is, if the payment is correct, monthly payment is correct, it has to be 24,000, which is the principal we owe. Then using that formula, right, which is PVA times R times 1 plus R raised to N, right? R times 1 plus R raised to N. At this point, some people may ask, oh, Professor, what happened to the outer bracket? Don't you need to put the that doesn't really matter here. Why? Because when you are multiplying something to a fraction, it gets multiplied to the numerator only anyway, right? So it doesn't matter, right? Whether with or without the outer bracket. Now here, when I say bracket, it also means parenthesis, because a bracket is 2 syllables. It's easier to say bracket than parenthesis. Parenthesis is like parenthesis, 4 syllables, right? Now then, what we need to do, you divide it by open parenthesis, and then 1 plus R raised to N minus 1. Okay, verify, right? That's the formula, right? And then hit enter. What do you get? You get exactly, right, 463.99. Okay, so this is the correct monthly payment, right? And we proved that they are ripping you off. They're overcharging in 2 ways, right? Now, so think about it. If you change this to this, okay, and then change this to 5 years, and then try this. Simply drag it down, right? Of course, you have to have RNN already. Drag it down. What do you think you will get there? You should get 24,000. Let's see if it checks out. Yes, of course, it checks out. Okay, so voila, we have found our conclusion. We reached our conclusion. Now, the next topic or next topic on the agenda is the amortization schedule. Amortization. What's an amortization? Now let's step back and go back to the stop sharing, and let me go back to whiteboard. So what does amortization mean? Okay, where did it come from? What does that mean? It means, paying down debt. Okay. But what does, what is paying down? I mean, there are some idiomatic expressions in English language like pay up, pay off, right? Pay down. Now, pay off, quite obvious. You completely pay off, right? If you owe any money, right, and if you pay off, right, your obligation is done, right? Or but then you also say pay up, right? So he's paid up, so so he's not going to come back, or some. I mean, if you say, but then it can have another connotation. Of course, if you say he's paid up, then he's paid to his satisfaction, right? But another interpretation of that is he got the bribe. He got paid up. He's paid up. That means it's like in a context you say we paid him up so he would keep quiet, right? Sounds like he took the money, right? Bribe, so he's going to keep quiet. Or but anyway, depending on the context, right? It can be interpreted that way. But also, then what's paid down? I mean, it sounds like you pay less amount. Now, what it means is the principal balance goes down as you make the payment, right? You make payment, gradually, so the amount you owe the principal balance goes down, so pay down. But then, what is the etymology of the word? I mean, what is the origin of the word? What's the root of the word? You might say, oh, what is the radical of the word? Of course, the verb is to amortize, right? But then some people might say, oh, isn't it, like in Italian or in Spanish, amor? No way. I mean, what does it have to do with paying down the debt? Now, the radical of the word, or the root of the word, is mort, right? And what does that mean? Well, a lot of English words or other Romance languages have the same root. I mean, same etymology. That means dead. In French, mort, dead, right? And also in English language, mortality rate. What does that mean? Mortician. What kind of profession is mortician, right? Or mortal, immortal, right? So what does it have to do with death? Well, what it means is the death of the debt, right? Amortize means you're bringing the demise to the debt, or you're taking that debt to its own demise, right? Demise, right? Why? Well, actually, what it is showing you is, let's say, this is timeline. This is the dollar amount, right? So at time zero, you had this much, principal, right? But over time, it is slowly, right? I mean, this is not a very nice pattern, but I would, yeah, it looks like this, right? And this is called decaying pattern, decay, right? Decay means what? When anything decays, it is going to its own demise, right? Decay, right? On the other hand, if it drops like this, it's called exploding pattern, or explosive, or exponential. Yeah, think about it. The decrease, it's decreasing, but it's decreasing at a faster rate, higher and higher, right? And then it gets, actually, the rate of decrease is going down here. I mean, if it is increasing, right? I mean, if it is like this, then that's explosive, right? But anyway, when it grows, if it grows like this, that is decay. If it grows like this, decaying pattern. If it grows like this, that's an exploding pattern, right? So anyway, enough of that. Now we're gonna go back to Excel. So I'm gonna clear out everything, right? I will leave the bottom. I will leave the bottom on because we can use it later, right? So first of all, this is a 5-year example. So there are 60 payments, right? This, in the column A, I put payment number, and there will be 60 rows up and down, right? And as we move up and down, we'll be losing the sight of the labels, so and the initial data. So what I'm going to do is I'm going to put the window pane there, right? Freeze pane. What does that mean? That means even though I go down, scroll down, I wouldn't lose the sight of the labels, right? And then again, these 2 rows are totally unnecessary, right? They are not related to our problem, so I can delete it, or I may use it. If you want to use it later, all you need to do is simply go to Home and Format and go to Hide and Unhide. You can hide those rows, right? So without deleting it, because we can, we may be able to use it later, right? Okay. Now, first of all, I'll put in the payment number. So just put 1, 2, 3. You just plant the seed, right? Seedlings of number, right? You don't have to put all the way to 60 because Excel is so smart. Excel is actually smarter than you think, right? So Excel understands your intention. If you put like 3 seeds of number and they are integers, right, with the the interval 1, right? Then Excel understands that you want to generate a series of integers with interval of 1. Excel understands that. So when you highlight those 3 cells and then bring the cursor there and then drag it down, you see Excel generates, right, the numbers all the way to 60. Right? That's how smart Excel is, Now, next, payment is in the first month you're making this payment, but also every month you're going to make that payment. So what do? You want to copy that and paste it all the way down. But you don't have to. If you copy and paste it, then what's going to happen? Just like that. If it is 823 here, it's going to be 824, 825, 826, right? So you don't want that to happen, right? You don't want it. You need to keep that data, right? You need to keep it in 823. So what do? You need to lock it into 823. So what do? You hit F4 and it locks it into that cell, right? And once you are done, just drag it down. All right, there you go. And that's the total amount. Because I already put auto sum there. It's going to automatically sum the what's in that column, right? Everything in that data range. Now let's figure out what is the interest paid. Now, as I told you, think about it. Each monthly payment consists of interest and principal, right? So how do you find the interest? Well, you might think, isn't the monthly interest rate 0.5%? So wouldn't it be this times that 0.5? No, not at all. Why? You pay interest on what? Do you pay interest on the payment? No, you pay interest. What generates interest? The principal, isn't it right? So you pay interest on the principal. So what is the principal here? This is the principal in the first month, right? Before you make any payment, you at time 0, your principal is this, and you pay 0.5% on that. So I'm gonna, right, and then times that. And then again, think about it. It's gonna be 0.5% through and through every month, right? So I'm gonna also lock it because that way I can just copy and drag it down. There you go. This is the interest paid. Out of what? Out of this, right? Then what's the principal paid? Of course, then the principal paid would be the difference between the 2. Isn't that right? If this is the interest paid, then the difference between the 2 is the principal paid. Isn't that right? So then that minus. Okay, that minus that. Okay, and then the principal balance. So after making this payment, how much principal is left? The principal balance is this is very logical and straightforward. It's not really difficult. Think about it. If from this principal, this much is paid, so then this principal would go down by as much as this, right? Isn't that right? So I'm gonna subtract from that, subtract the principal paid. There you go. Good. So in the second one, maybe you think, oh, it's gonna, repeat. So I'm gonna drag that. No, that's not right. Why? But just for the structure, I will copy it anyway for the structure. Now, take a look at this. Yeah, interest rate is correct. But what would be what would be G24? G24 is hidden now, right? Remember, we collapsed those rows, so it's hidden. And if you remember, there was nothing there. So this is not the correct principal it must be pointing to. Remember, this was the principal at time 0, but after making this principal payment, then this is the new principal balance at the end of month 1, right? So it should be pointing to this, right? There you go. You're good now. So let's check. Okay, that's logically correct. And what about this? Again, G24. You remember, there's nothing, no data, right? So that means at the end of the first month, this is the new principal balance. From that, it's going to go down by as much as this, right? So you simply do that, and then from there on, you're home free, right? All you need to do is simply just drag it down. There you go. We'll make it 2, right? So what is that? How we completely amortized it. Why? What is this column? What's this column? That's the principal balance, right? The column is the principal balance. So maybe I should put the freeze pane there, but that's fine. If you, by the end of month 60, you should have fully paid off your principal, right? So the balance should be 0, right? Makes sense. So principal balance is 0, so we have paid off. It checks out. And what is this column? Wasn't this the column of the principal paid? Yes, that's the column of principal paid. So let me do this. I'm gonna and freeze pane again. Now then, that's the column of principal paid, and the sum of all the principal paid must be exactly equal to 24K, right? Principal paid must sum to 24K, so it did. And then this is the sum of all the interest paid. This is the sum of all the payments. But logically, right, simply logically, the payments, sum of all the payments must be equal to interest paid, sum of interest paid, and sum of paid. And look at that. The number exactly checks out. This is exactly also this plus this, right? So our schedule, right, is complete, and it's immaculate, and it checks out, right? It's immaculate, right? In the old days, people couldn't build, amortization schedule. It was, something for only for like, actuaries. Actuaries are the mathematicians who do this type of calculations, or finance experts, finance professionals, or accountants, or economists, right? And these days, you have financial calculator app, free financial calculator app on your mobile phone or other mobile devices. You can. Some of them have amortization schedule feature, but there's a big difference in knowing how to just plug in the number into that app and knowing it, personally knowing it, personally understanding the logic behind it, the rationale behind it, right? And actually being able to build it, right? Now, so what does this mean? What does this amortization schedule tell you? For example, first, it's obvious how each monthly payment breaks down into interest and principal, and you can. There's something you can notice. What you can notice is that the early on, the interest is the highest, right? And as time goes on, interest gets smaller and smaller and smaller. And early on, the principal paid is smaller, the smallest, and as time goes on, it gets bigger and bigger and bigger. So if you understand the amortization schedule, this is why you would understand that the way it is structured, the payment is structured, is not in constant proportion. For interest, it is in decreasing, right? Structure, right? And in terms of principal paid, it is an increasing structure. And this way, what does that mean? The lender maximizes on the interest. Now think about it. If you've been making payments, okay, you've been making payments well up to, let's say, this point, 12th month, and let's say you cannot, you default and you cannot make payment anymore. What's going to happen? The lender is going to repossess your car, isn't that right? And if the lender, by the time the lender repossesses the car, then they have collected the largest amount of, most of the interest, right? In other words, it's not the smaller part of the interest that they have collected. They have collected, the bigger part of the interest. And then you might, what about the principal? Well, they can resell it, right? When they repossess, and they can resell it. And if they resell it, at this value or above, right, they're not losing anything. And from there on, if they are selling it at that right price, and then that means either make a loan. If they make another loan for that amount, right, and then the interest will continue. If they just sell it off, they will get their principal back, and until then, they have maximized their interest, right? So that's one thing that the amortization schedule can show you. And also another thing is, let's say you came by a large amount of money, right, by the end of 12th month, and you got tired of making monthly payments, so you want to pay off or buy it out. Then what's the payoff amount, or what's the buyout amount? This is the buyout amount, right? That's the only principal you have left. You don't have to worry about the interest from there on, because interest is only, you incur interest only when you have remaining loan, but you don't have any loan once you pay it off, right? Of course, the lender will say this is not the exact buyout amount. Yes, of course, because why? Because there's some transaction cost, right? They will just, but no, pretty much, this is the the balance, loan balance left. They will probably adjust it by like $20, $40 maybe for transaction fee, right? Okay, that's it. That's it for today. So that's the amortization.
Okay, so that's the end of present value of annuity part 2. So we're gonna take, actually it's 7:22. We're gonna take a 10-minute break. So, and reconvene at 7:32, and then we're gonna do the Excel exercise, right? Hands-on exercise. Okay. So let's take a 10-minute break. Okay.
Thank you, Professor.
All right. You're welcome. Let's see you in 10 minutes. All right, we're back. We're back. So now let's take a look at um, the third bottom tab in this file, right? Remember, we worked on this file yesterday, right? The time value of money uh, Excel file, right? You downloaded it from, right? Topic 3 folder, right? Time value of money dot Excel, right? This file, right? Worked on it. So please pull it up. And this one is over. Okay, so I'm gonna have to close it. So do you all have it in front of you? Hmm? Everyone, do you have it all in front of you? Okay, I need some confirmation. Do, does everyone have this file opened in front of you? Right?
I'm
Okay.
looking and finding it.
Okay. Yeah. Uh, I'm sure you have it on your computer yet because you worked on it yesterday. Um, but if you didn't save it, I mean, well, it was in your best interest to save it yesterday because your work, right, the result uh, of your work is saved there. So if you have, if you saved it, then uh, you have that result, and then of course, if you didn't save it, you can download it again, and then work on it later. But today we are doing the multiple cash flow model, so you need to click this bottom tab, right? You need to click this. You need to select the bottom tab. Okay. Let's see, two people in the chat box. Okay. Only three people said yes. Only three people said yes. I don't know what. I will have to. I will have to assume. I'll have to assume that the rest of the class also has it, right? So let's start on. Let's start with this uh, table, the first one, right? So this is future value of annuity example, right? And this is exactly the first example we did. Remember the graduate school fund, right? So you are trying to save money for graduate school. Your target future value is $60,000, right? That's for MBA program, 2-year MBA program. Of course, if it is CUNY, right? It could be only CUNY can be this cheap, 60K. But anyway, that's your target future value, right? So currently you are uh, you are planning on saving $800 every month, and the bank interest rate APR is, or prevailing market rate is 6%. Uh, and that's quite realistic now because Fed funds rate is 5.5. The bank will give you maybe not 6%. Um, if you borrow, then maybe more than 6%. Um, if you borrow, the prime rate will be about 9%, right? Because you remember prime rate is about 3% above the Fed funds rate. But if you lend, so this is lending to the bank because you're saving. It will be about, probably you might get 4% or 5% if lucky. But anyway, your timeline is 5 years. making monthly payments. So M is 12. And we already know R, the periodic rate, and N, it's the same old story. Okay. My keyboard has gone. My keyboard has gone to sleep. Now, yeah, okay. So, okay, that's going to be, we know that. Monthly 0.5%. Total number of compounding, we know there are 60 months, right? Which is T times M. There you go. So the future value of annuity is using this formula, right? Payment times open parenthesis 1 plus open another parenthesis, right? And 1 plus R raised to N minus 1 close parenthesis and divided by R, right? And there you go. So now but however, please don't forget, this is not the final answer. Why? Because this is not enough. Isn't it right? You need $60,000 to fund your graduate MBA program, graduate school MBA program for 2 years. So you're still falling short by about $4,200, right? So you explore other options. One option is increase your monthly deposit by $60. Another option is find a bank that pays a better interest rate. Another option is extend your timeline to 6 years, right? But all of those options can be evaluated simultaneously, right? All of those options can be evaluated simultaneously by, if you do one problem, then all of them can be done almost immediately, instantaneously, right? This comparison can be made. So, okay, this hits the nail on the head. I mean, it's not exactly 60K. It overshoots 60K by $2.23, but it's almost as good. I mean, it's very close. Third option, higher interest rate, 8%. Still, you are still about $1,300 short. Extending your timeline by 1 year, right? You overshoot the target by $9,000, right? So I don't know if you think graduate school is not that urgent. If you think graduate school can wait 1 more year, then probably you can choose this option. But if you don't think, if you think graduate school cannot wait, then I think this is your best option, right? And this is ordinary annuity, and then let's see what the annuity due. Let's see what the annuity due will what it will do, right? What difference it will make. It won't make that much difference, but at least annuity due will be better, right? And what did I say? Annuity due is just one more compounding, right? Annuity due is just one more compounding than ordinary annuity. So we recycle the ordinary annuity result and give it one more compounding. Plus R and then we drag it down. Okay, so it's still better. I mean, see, this is about $300 better. And this one is slightly better, not that much better, right? About yeah, $200 better. But annuity do still more money, right? Because there is always one more compounding, right? Now, row 7, this is about nailing the exact payment, right? Because we have the target future value. So, and we know what interest rate is. We have our timeline. So we can solve this equation for payment. So, and then we can tell what is the exact payment, exact deposit that you will have to save every month to reach this target goal at the end of month 60, right? So all you need to do, of course, I'm gonna just copy this, paste it here. Okay, and then think about it. This is the if you solve this equation for payment, it's going to be this. So payment equals, right, FVA, future value of annuity, times R, or open parenthesis, one more, 1 plus R raised to N minus 1, close parenthesis, right? Hit enter. It comes to 859.97. So then think about it. Second option, when you increase the monthly deposit by $60, that's almost close, right? And then when you did that, you overshot the target by only $2, $2.23, right? So the exact monthly payment that will achieve this, that will hit exactly achieve 60K, the target of 60K is this. Now the next question is, what should be the what should be the interest rate? I mean, you have your exact monthly payment that will get you to 60K. Then, and you have your timeline of 5 years. Then what should be interest rate? Okay. So we need to first solve for the periodic rate, and I told you there's no singular mathematical solution for rate in annuities. So we have to use, it's trial and error method. Basically, it's trial and error. So and what the computer is, that's what the computer is good for, trial and error method, because human, it will take many years or thousands of hours for humans to do the trial and error method, right? To reach, to pinpoint the exact answer. But for the computer, it's just a couple of a split second. I mean, they can do this reiteration. The computers can do reiteration, right? Thousands of reiteration at a split second. So we're gonna have to use Excel's built-in function, which is if you click on that, that's function, right? That says function of x. And most recently used functions will come up first, and rate function I haven't used. So I'm gonna go into the drop down menu box and select financial. Scroll down until you find rate. There's the rate. Okay. Now, and then you give it what it's asking for. N periods, number of periods, right? N periods. So select N, 60, right? Payment. This is the payment. However, you will need to make this negative, right? You'll have to make this negative. Why? Because that's the cash outflow, right? Cash outflows are expressed as negative on on financial calculator. Because think about it, it leaves your pocket, so it's minus, right? Right? Um, and cash inflow. This is cash inflow. That's always cash inflow is positive. There's no present value. There's no present value. Think about it. This is annuity, so it's not a single cash flow. It's not single lump sum. There's no single lump sum cash flow, right? Other than the future value, right? So no present value. Let's skip that. Future value. This is the future value, right? Type means whether it is ordinary annuity or annuity due. And if it is ordinary annuity, you leave it blank. Enter 0 or leave it blank because, and if it is annuity due, you enter 1 there. And what is the reason you enter 1 if it is annuity due? And I've been explaining this to you over and over. The only difference between ordinary annuity and annuity due is one more compounding, right? One more compounding. Annuity due has one more compounding than ordinary annuity. That's why you enter 1 there. However, this is annuity due. Okay? Unless there is a specific mention that this is an annuity due, the default is ordinary, right? Also, in our scenario, you're making this deposit at the end of every month. Think about it. You have to get a job to make this monthly deposit, right? So when you start the job, you cannot make that deposit unless you already have it. But by the end of the month, you will have that money. You get paid, so you can make a deposit, right? So it's ordinary annuity is assumed by default. But once you have entered all of these, you see something already here. It says 0.005. So it's already giving you 0.5%. So if you hit OK, 0.5. But again, the problem is asking for annual rate. Now think about it. Always from the topic one, it was clearly established, right, that all interest rates are expressed as annual, right? And this is monthly. So to turn it into annual, all you need to do is this times this, right? Okay. Now, next question, how many years will it take? Now we know what monthly payment we're going to make, what is the annual interest rate, and what is our target future value. Then our next question is, how long will it take? How many years will it take? Right? And for that problem, we have the formula. Of course, this is only present value of annuity formula. Present value So for future value of annuity, for the time for solving for time in future value of annuity, right? The formula is, oops, not this one, but where is it? Yeah. Okay, for future value of annuity, it's going to be natural log of this, right? Over natural log of 1 plus R, right? So first, I'm going to have this, right? Which is, I can simply divide it by 12. And then, okay, so it's the natural log of 1 plus future value of annuity over payment times R. Okay? Now, when you multiply this to the fraction, it gets automatically multiplied to the numerator only, unless you put parentheses here, right? So this is okay. And then you close it, then divide it by natural log of 1 plus R. And I know what this is going to give because it should give us 60, right? And let's see if it is true. But everyone is okay so far? Everyone is following? Everyone is okay? All right, so
Yes.
enter. Okay, very good, very good. So if you hit enter, you'll get 60, right? And that means 60 months. So to convert it into years, you need to divide this by n, right? 5 years. There you go. You're all set. Now this one, I'm not gonna go over this because this is just another variation of, under different scenarios. Same problem, right? 60K, but different interest rate, different M. So I'm gonna skip that, and I'm gonna go to the present value of annuity problem. Present value. First of all, I'm gonna do this one first because this is the lottery example, right? Remember, this is the lottery example. So so our question is, if you're receiving, you won the lottery, right? Was $10 million, I guess, 10 million jackpot, $10 million, you won it, and the question is, are you gonna choose lump sum or are you gonna choose annuities? And the only way to make that decision is, I mean, if you choose lump sum, you get about 60%. In reality, maybe you probably get even less than 60%. But let's say 60%. So 6 million if you choose lump sum. If you choose annuities, it's going to be like $20,000 every month for the next 30 years. Okay. So which one is better? Of course, lump sum is already in present value, right? Because if you choose lump sum, you get 60, you get 6 million in today, so it's already in present value. If you choose annuities, there's gonna be a cash flow stream, right? Monthly, $20,000 for the next 360 months. So you need to only, you need to convert them into present value of annuities. So then you compare present value with present value. So of course, you're gonna have to first find what is the monthly or periodic rate. Okay, of course, if APR is 6%, it's going to be 12, and it's going to be 360 because 30 years by 12 months, right? 360, right? And applying this formula, present value of annuity formula, right? Which is payment over R minus payment over R times 1 plus R is 2 and close parenthesis. And everyone is okay up to this point? We hit enter. Comes to 3.335 million. 3.335 million. And obviously then your choice is lump sum in this case, because if you choose lump sum, 6 million in today's dollars, right? Present value. If you choose annuities, it's only 3.335 million. So who's going to choose annuities if this is the case? However, if the prevailing market rate is just 1%, that's the case, all you need to do is just drag it down. And then your choice is clearly annuities, because the present value of annuities is 6.218 million, which is greater than the lump sum, right? Now, the next question, next example is car payment, right? Car financing. I think someone dropped something. Someone dropped a line in the chat box. Let me check that chat box first. Okay. I'm checking it on my other computer. Okay. That was just yes. So if also the same interest rate in 5 years, right? So we know periodic rate is 0.5% and total number of compounding is 60, right? 60 months. You're making $500 payments, right? At 6% APR for the next 5 years. So 60 payments, right? And is this a good deal or bad deal? I mean, in the scenario, right, in our example, the price of the car was $30K. You made $6K down payment, right? 20% down payment. And the financed amount is $24K, right? So if the present value of all these $500, right, for the next 60 months, right, all these 60 payments of $500, present value of all that is exactly 24K, then you're right on the money, right? You're right on the money. I mean, it's the fair deal, right? Exactly. However, but so is that really the case here? So let me just drag it up and see. Oh, the present value of all these $500 is actually 25.862K. So you're actually paying $1,862 more than what you owe. So this is a bad deal. You're being ripped off, right? You should be ready to file a lawsuit. So get a good lawyer, right? Now, on the other hand, we can also figure out, we can nail the exact payment, right? So of course, in 0.5 monthly payments, 60 months, right? And by solving this equation for payment, we come to this, right? So we can solve for payment, right? Formula is, so PVA times, that's your original principal, right? PVA times R times 1 plus R to the n. R times 1 plus R is to n over, open parenthesis, open 1 plus R raised to n, n here. What's happening? F2. If you hit F2, you can see E22 raised to F22. That's correct. Minus 1. Correct. That's the formula. Okay. All right. So hit enter. What's going on? Hit F2. G23. Oh, why E2? E23. E23. F23. Okay. What's going on? F. G23 times E23 times 1 plus E23. Why is it doing this? Raised to F23. Okay. Enter. Yeah. So we nailed the exact monthly payment. And this already tells you that you've been overpaying, right? If this is what you've been paying, you've been overpaying clearly, right? By about $36 every month. Okay. So now let's build the amortization schedule. I made a lot of. Let me erase all of these because I made a lot of marks on. Okay. So this amortization schedule may look a little different from the one in the video. Just a little different. Why? Because in the video I didn't have this column, the column of beginning principal balance. But adding a beginning principal balance makes it a lot easier, right? So I basically separated beginning balance and ending balance. So here, and of course a payment number, and I already put it there, but from the video that you can generate a series of numbers, and also okay. So here I'm gonna select the cell, and I think it was view and select freeze panes. So then if you do that, right, the top, you don't, it's fixed, right? The top of the spreadsheet is fixed at row 21. I mean, I should have brought it a little. Okay, it's okay. It doesn't really matter. But as I scroll down, or scroll up, or scroll to the right, it is always, hinged on this cell, so you don't lose sight of what was the payment, what was the original principal balance, what was the interest rate. Okay. Anyway, so in the first month, at the beginning of the first month, your principal balance is exactly this, isn't it right? Because it's the beginning of the first month. You haven't made any payment. You have the entire principal balance, facing you. Okay, and then payment. Payment is this every month. So as you drag it down, as you copy and paste, you don't want it to change, so you lock it by hitting F4. You hit F4. If you hit F4, then these dollar signs will automatically appear, right? That means you're locking column A, and you're locking in row 23. You're locking in column A, locking in row 23. So it's not going to change. The data value will be locked there. And then interest paid. So in the first month, as I said, monthly interest rate is this, and that monthly interest rate is gonna be that through and through, right? So you also lock it by hitting F4, and then you pay 0.5% of what? The principal balance, right? Principal balance, beginning principal balance, right? So there you go. And then the principal paid is the difference between the two. Out of this payment, if this is the interest paid, then the principal paid will be the difference between the two, right? Ending principal balance will be, this was the beginning principal balance, right? And it goes down by as much as that, so it's going to be, right? And then at the beginning of month 2, this will be the beginning principal balance, right? Think about it. Ending principal balance of the first month is the beginning principal balance of the second month. Isn't it right? There you go. And then after that, yeah, that's how it is. And from there on, all you need to do is just select all those cells, just drag it down all the way until you come to 60, month 60. And then, how do you know if you got it right? You will know that you got it right if, okay, let me also do something on my other computer. You will know that you got it right if you see 0 as the ending principal balance at the end of month 60, right? And this row is the sum, right? I already built in sum there. So if the sum, this column is the column of the principal paid, isn't it right? So if the sum of the column is 24,000, it checks out. Isn't it right? That should be the sum of the principal paid. And then sum of the interest paid, right? This is the column of interest paid. So sum of that column is this. And if this plus this, sum of the interest paid and sum of the principal paid is the same thing as sum of the total payments. Yeah, and they are. It's equal to, sum of these two is equal to the sum of all the payments. Then it checks out, right? So any questions? Any questions? Everybody got that right?
No, no question.
Okay, all right. That's a very encouraging sign. All right, so then that wraps up everything about the multiple cash flow model. So let's call it a day. Actually, call it a night. And so have a go in peace, and I will see you guys all back on Monday. Okay, and don't forget the quiz 1 starts tomorrow, right? All right, take care, everyone, and I will see you on Monday.
Have a good weekend, Professor. Stay safe and enjoy.
All right, you too. Thank you. Stop recording.